To understand rocks, crystals, and gems, we need to start with minerals. As we already learned, minerals are naturally occurring solids with atoms organized in a pattern. They make up rocks, which are solid collections of one or more minerals. Basically, you can think of minerals as ingredients, and rocks as one of the things those ingredients can make. Minerals can also make up crystals. Crystals are solids with atoms organized in patterns. Now, you might be thinking, wait, isn't that the same thing as a mineral? Well, minerals and crystals are closely related, but they aren't exactly the same thing. The organized atoms in each mineral naturally form a certain repeating geometric shape, like a cube or hexagonal prism. When these patterned groups cluster together, they form crystals in those shapes. So, crystals are made of minerals that have collected in unique formations, and just about every mineral can become a crystal under the right conditions. So, how does this happen? Well, minerals are often dissolved into liquids like water or magma. Over time, these minerals might separate out from the liquid. Remember, the atoms in minerals have an organized pattern. So, as enough of the mineral gathers together, they naturally fall into these patterns and create repeating geometric shapes. Some crystals, like diamonds and sapphires, get a special name: gemstones. A gemstone is just a particularly rare or beautiful crystal that has been cut, shaped, polished, and used by people for some special purpose, like jewelry. In fact, some gemstones are made out of the exact same minerals as another more common crystal, but we call the particularly rare and beautiful form a gemstone. For example, graphite and diamonds are both made from carbon, but we use one for precious jewelry and one for making pencils. Tough break, graphite. So, we know minerals make up rocks and crystals, and that gemstones are basically just extra fancy crystals. But just like how there are overlaps in how igneous, sedimentary, and metamorphic rocks form, there are also lots of overlaps in how rocks, crystals, and minerals form. Many rocks actually have crystals and even gemstones inside them. So, how do you think this happens? How do the processes that form rocks, crystals, and gemstones overlap? Pause the video here and record your thoughts in your guided notes. Remember, crystals can form from minerals dissolved in magma, so they often form in igneous rocks as they cool and harden. They're especially likely to form in intrusive igneous rocks that cool slowly under Earth's surface, which gives the crystals plenty of time to grow. For example, the igneous rock granite often has chunks of quartz crystals in it. Crystals can also occur in sedimentary rocks. What kind of sedimentary rocks do you think crystals are most likely to form in? Remember, chemical sedimentary rocks form from minerals that were dissolved into a liquid, which is similar to how crystals form. So, these two processes often occur side by side, making sedimentary rocks that are flecked with crystals and gemstones. For example, gypsum is a sedimentary rock made up of tons of teeny tiny selenite crystals. Sometimes the crystals are way bigger though, like the deposits of the gemstone turquoise, often found in the sedimentary rock sandstone. There's also a unique kind of rock-crystal hybrid that these interconnected processes can sometimes form: geodes. A geode is a rock with an empty space in the middle that's filled with crystals. This usually happens either when an extrusive igneous rock cools around an air bubble, or when some pieces break off a sedimentary rock and leave an empty space behind. Then, water full of dissolved minerals seeps into the empty space in the rock. Over time, the water evaporates, but the minerals stay behind, forming these beautiful crystals. But wherever they're found, minerals, crystals, rocks, and gemstones all have tons of uses. We use them to make tools, to build our houses, to create parts for electronics, and even just to wear, like that $71 million gemstone that started this whole lesson. It's sold for so much because it has some unique qualities. The intense heat and pressure under Earth's surface just slightly changed the pattern that this diamond's atoms crystallized into. This changed how light hits it, which makes us see it as pink instead of the typical clear color of diamonds. Plus, it's huge, and a gemstone getting that big is rare in itself. Now, is it $71 million worth of huge and rare and pink? I mean, I don't even think that number would fit on a price tag. But as a unique creation of the countless interconnected processes that are constantly shaping our planet, well, that sounds pretty priceless to me. Now, let's review what we learned today. Now you know that minerals are the building blocks of rocks, crystals, and gemstones, that each of these forms through different but connected processes, and that the overlaps between these processes can form crystals in rocks, geodes, unique gemstones, and more. But wherever there